Hey all, my name is Digant Mishra. I'm from KIT University of Bhubaneswar.
Hello, I'm Akshat Aman from Bhilai Institute of Technology, Durg, Chhattisgarh.
Hi everyone, I am Meera Shashindran from Vidya Academy of Science and Technology, Thrissur, Kerala.
Ever intrigued about learning about cosmology and astrophysics? Well, this project by us revolves around the concept of classifying galaxies into the three major classes: spiral, elliptical, and irregular by using a convolutional neural network architecture. Let's look about the same in the upcoming sections of the video.
Starting off, we have the IPython notebook for training and defining our model architecture based on our image dataset.
This is the IPython notebook for training our model on defining our architecture we shall be using for the problem statement, which is to classify images into the categories. We can see we have a four deep layer convolution neural network and we are using softmax at the end because we have three classes. We are also using tanh because after implementing that we found out that accuracy was hugely amplified. This is just visualizing the first filter of the first layer, and to do it on our local system we ran it for 40 epochs at compressed images of 128 by 128, and we can see the accuracy was pretty much at 95% for training and 94.75 for validation. Then we saved the model as a h5 file, the weights of the model, and we plotted the accuracy curve for 40 epochs, and we can see that it is having no such bias or variance at all.
Up next, we have the code for data augmentation.
Since we had very less amount of data for irregular data set, what we did is we used the augmenter package and we augmented from 11 images found. We augmented and printed out 1300 more images from it so that we don't have a class imbalance between our data sets.
The following is the IPython notebook for testing our trained galaxy classifier CNN architecture model.
We have the IPython notebook for testing or applying the trained model on new images and seeing how it performs. We are taking a set of images for all the three classes which the model has never seen or has never been trained upon, and the labels were the same, you can see on the screen right now. And what we did is we had saved the weights of the already trained model in a h5 file format, and we just import it and also draw the same architecture we had used while training. And after that we tested for the elliptical test data, and we see that every single one of them has been assigned correct predictions. Also for irregular, we had 5 incorrect and 59 correct out of 64 predictions. And finally for spiral, we were correct in all of the predictions. And this is just visualizing some of the test data we had at the hands, and we can see it is pretty much not of the same size.
Upcoming is the IPython notebook for visualizing how each galaxy image transforms to the first layer of convolutional neural network.
Here we can see that we have the IPython notebook for visualizing a spiral galaxy image and how it transforms to the first layer of the convolutional neural network. And here you can see this is the visualization without using pooling for only the first layer of the convolutional neural network, and this is the visualization for the first layer with pooling, and lastly we visualize how the image transforms to the second layer with pooling. And this is the visualization for the plotting of the accuracy and the loss curves across 200 epochs after being run on the GPU servers. You can see the accuracy pretty much went up to 90.
So this was all from our side. Hope you guys like it.